The long run behavior of our graphs is talking about what happens at the ends of our graph, or specifically what's happening as x goes out to positive or negative infinity. So it's kind of like we're looking at the right-hand end and the left-hand end for what is our graph doing. And with polynomials, what should be happening is our graph is either going up to positive infinity or down to negative infinity. So this first graph here shows our even powers. So if we graphed x squared, or x to the fourth, or x to the sixth, what you can see is the common behavior between these is that if we read this left to right, we're starting up here at positive infinity, we come down, we go through 0, 0, and then we go up to positive infinity. So the long run behavior is at the ends of these graphs, like where we have the arrows going up in both of the sides here. Inside here, like around what's happening at the origin, this is called the short run behavior, which we'll talk about in a different video. But really, we're just focused on the ends here. So with even powers, as x goes to positive infinity, we want to be able to describe what our function is doing. So my notation here, so as x and then arrow positive infinity, this is read as x approaches positive infinity. And what that means is if you imagine starting here at 0, 0, it's like what's happening as I walk to the right-hand side of the graph here. What's happening as x is getting larger and larger and larger? Well, our y values are getting larger and larger and larger. With those arrows going off to positive infinity, that tells me that my function outputs are just getting bigger and bigger and bigger. So how I would write that is as x approaches positive infinity, f of x approaches positive infinity. Then what I could also describe for the long run behavior is as x approaches negative infinity, and saying what does f of x approach? Well, as x approaches negative infinity, that would be the equivalent of if I'm standing at the origin here, what happens as I walk to the left? So as x is getting smaller and smaller and smaller, our y values are getting bigger and bigger and bigger. With these arrows going off to positive infinity, that tells me that my function values are going off to positive infinity. So with even powers, the long run behavior matches on both sides. Like in this case, on both sides of the graph, we're going off to positive infinity. Now, so this is going to happen when we look at polynomials that have a leading term that is that has an even degree. So up above, we looked at these different degrees, 3, 5, and 3. So actually, all of those graphs are going to tie to this odd power section. But if we had had one of these that had an even degree, so like a degree of 2, a degree of 4, or 6, then what we could do is we'd have an idea of how our graph begins and ends in terms of going off to positive infinity. So this is where we're going to start evaluating the leading term. So we're going to look at this leading term when we evaluate these an x to the n. And for the general shape, we're looking at the degree. We're also going to look at the leading coefficient. So all of these cases, I mean, we talked about quadratic functions, and what we can see is with this red line, that's our parabola, and it's opening upwards. So what would happen if my leading coefficient was negative? It would be opening downwards, and that's true of all of these. So what I'm going to do is make a little note underneath. What if our leading coefficient was negative? Then what would happen is as x approaches positive infinity, then f of x would actually go to negative infinity, since it would be going down. And then as x approaches negative infinity, so as we go to the left of our graph, f of x would also approach negative infinity there too. So what this would be doing is giving us that opening down scenario. So we'd be going to negative infinity on both sides. So that long run behavior changes whether that leading coefficient's positive or negative. All right, so even powers, this is when n is even, so we have an even degree. This would be our general shape, but again, as we add and subtract more like different terms into our polynomial, those are going to change the short run behavior. But in terms of long run behavior, all we need to do is look at that leading term. So what if n is odd? What if we have an odd degree for our polynomial, like up above? Then what we have is something that looks generally like x cubed. So we're starting down at negative infinity, we come up and twist, and we kind of flatten across 0, 0, and then we go up to positive infinity. So it's always increasing across the entire graph. And we have this kind of flattening, but again, this flattening here is the short run behavior. We're really focused on what's happening at the ends here. So let's describe our long run behavior. So as x approaches positive infinity, as x approaches negative infinity, what is f of x doing? So as x approaches positive infinity, so as we're going to the right-hand side of our graph, our function is going up off to positive infinity. So as x approaches positive infinity, f of x also approaches positive infinity. As x approaches negative infinity, so as I go to the left-hand side of the graph, our function is going down, 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 which means we're going off to negative infinity. All right, so let's talk about what would happen if our leading coefficient was negative. If our leading coefficient was negative, what would happen is we're basically reflecting across the x-axis. So what would happen is the left-hand side of our graph would start up at positive infinity, and then we'd be coming down, decreasing, flatten across 0, 0, and then decrease off to negative infinity. So with that, our long run behavior is going to switch. So as x approaches positive infinity, now f of x is going off to negative infinity. And then as x approaches negative infinity, our function would be approaching positive infinity. Since as we go to the left-hand side of the graph, our function's getting bigger and bigger and bigger. All right, so this is our notation for long run behavior, using those arrows to represent kind of the word approaches. And it's really talking about what happens as we go to the right-hand side of our graph and the left-hand side of our graph. And basically with polynomials, it's a matter of, are we going off to positive infinity? So are we going up, or are we going off to negative infinity, which would be going down?